MAT1033 Final Exam Review question number 79. We have a problem that the directions just tell us to graph. We have x equals -3. Now that's one of our special linear equations. It is the equation of a vertical line. We can use an XY table to graph that, and because there's only the single variable, x is always equal to -3. So I'll just show it for 3 points, and then y is any value I want, any real number value, so -1, 0, 1. I plot those 3 points on the coordinate plane, so -3, -1, and then -3, 0, -3, 1 connect, and you see that this is a vertical. It doesn't look very vertical, does it? But this would be a vertical line. See if I can get it to draw a little bit straighter here. This connecting those points would be a vertical line. MAT1033 Final Exam Review question number 80. We are to graph, and we're given an inequality 2x minus y is greater than or equal to 4. To show the solution set of ordered pairs, we graph this in a plane. Remember, this is the one that's got the 3 parts. The first thing you do is graph what's called the boundary line, and that'll be the boundary between the ordered pairs that make the inequality true and the ordered pairs that don't. And the boundary line is 2x minus y equals 4 using an XY table. If x is 0, y is -4. If y is 0, x is 2. And then the second thing that we do is it dashed or is it solid? And because of the equal to part of the inequality, this is going to be a solid line. And then the third thing that we do is we decide where we're going to shade. And we were using a test point when we were doing these problems in class. So let's go ahead and graph what we have. We've got 0, -4. And we've got 2, 0, and we know it's going to be a solid line because of the equal to part in the inequality, so we're going to sketch in this solid line, and then we have to decide, do we shade above the line or do we shade below the line? Well, again, what we were doing is we were looking at a test point, and we'll use 0, 0. Unless the line passes through 0, 0, then we would pick another point that wasn't on the line. So the test point is 0, 0. We plug that into the original inequality, 2 times 0 minus 0, and you ask yourself, is that greater than or equal to 4? Well, is 0 greater than or equal to 4? And the answer is no, so we would shade on the side of the line where the test point isn't. Now, if the test point had made this true, then we would be shading over the test point. But because it makes it false, we shade below the line in this particular case. There was an alternate way to determine whether we shaded above or below the line. So if we take this and solve for y, 2x minus y is greater than or equal to 4. -y is greater than or equal to -2x plus 4. Divide by -1. When we divide an inequality, remember we need to reverse the symbol. So that'd be 2x minus 4. And let's just verify. Here's the y coordinate of the y-intercept, and that agrees with what we did over here. And it has a slope of 2, so if we move up 2 over 1, we're back on our line. And it says y is less than or equal to 2x minus 4, which means shade below the line, and we shaded appropriately. So this is the correct depiction of the ordered pairs that make the original inequality true.